Welcome to Brain Vision.
This is chapter 27, problem number 48. We have a DC motor with an internal resistance of 3.2 ohms. This is the internal resistance. And the potential supplied to the motor is 120 volts. However, the EMF in the rotor is 105 volts due to this internal resistance. So in part A, we're trying to calculate the current drawn by the motor. So we're looking at the current here in part A. Well, in order to get there, of course, the supplied voltage has to be equal to the EMF that we have in the rotor plus the potential across this resistor, right? Internal resistance. So then here, if you're trying to calculate the current, then the supplied minus the EMF divided by the internal resistance is going to give us the current drawn by the motor. So then 120 minus 105 divided by 3.2 is going to give us 4.69 amps. In part B, we are to calculate the power delivered to the motor. So it's simply the current times the supplied potential, right? So then it's going to be equal to 4.69 amps times 120 volts. What we have is 562.8 watts power delivered to the motor. However, there's the power developed by the motor is much less, right, due to this internal resistance. So then it's going to be equal to IV supplied power, what we calculated here, minus the power dissipated due to this resistor, I squared times R. So I times we supplied, we calculated it to be 562.8 minus now 4.69 squared times 3.2. So when we do this calculation, we're finding the power developed by the motor to be 492.4 watts.